The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.
Ben, you're going to be so proud of me. I did a lot of research over the weekend. I brought in this equipment, and everyone who watches this episode is going to dream about casting. So, just like we wanted.
Wait, are you sure you read the fine print of the job description? It's not a fishing show. We're actually doing a project involving the Sega Dreamcast, which is a video game console.
Oh, so I completely missed the point?
Yeah, it has nothing to do with fishing whatsoever. Yeah.
Amazing builds, exclusive mods, cutting-edge ideas, electronics, engineering, and more. Every week on Element 14's The Ben Heck Show.
In today's episode, we're going to hack up the Sega Dreamcast into a smaller, battery-powered, portable version of itself. I've done a lot of projects like that in the past, so this should be a cakewalk. Ha 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 ha. Let's look at the steps. First, we're going to take apart the Dreamcast and the LCD. I think for the screen, we'll use the classic Sony PlayStation 1 LCD screen. It's perfect size. Then we need to get the Dreamcast and the LCD to run off batteries. That's probably going to be one of the major challenges. What is the smallest amount of batteries we can use to give a decent amount of power to the screen and the Dreamcast? Because there's a spinning disc in there, so that takes a lot of energy. Then we're going to modify the Dreamcast controller to be smaller. The Dreamcast controller is kind of ungainly and big, plus it has those virtual memory unit things that stick in. Modifying that is going to be a bit of a challenge, but we'll figure it out. Then, once we have everything shrunken down, design a custom case around all of the parts, so that'll be the fun part, making it look cool. And then finally, assemble the case, test, wire, and play the unit. Let's get started. Let's take apart the Sega Dreamcast. All right, it's got a lid. I miss the good old days when there were really obvious screw holes on everything, and they were Phillips. When I was your age, we had to use Phillips screws and walk uphill in the snow to school both ways while fighting dinosaurs. And we liked it, and we didn't complain. Oh, I bet there's gonna be a screw under this. Came with a modem. Oh yeah, 56K, baby. And of course, there's a screw under it. Oh, that just comes right off. Oh, don't need that anymore. The challenge with making this into a portable is going to be its thickness. If you think about something like a PlayStation 2, it was kind of flat and wide, which meant all the components in it were fairly thin. And they were more to the side of each other rather than stacked. This is stacked, much like a GameCube. But a large portion of it appears to be this power supply here, so we can remove this for starters. Oh look, it's conveniently labeled. It shows exactly what voltages it uses, 3.3, 5, and 12. Pretty standard stuff, and then 2 grounds. So this is a pretty thick wire here, so it's probably disconnecting the entire AC when you push this switch, and then the power circuit engages. The power switch here is pretty rudimentary, which tells me as long as we activate these voltages all at the same time, it should turn on normally. Okay, so this we don't need. Oh, there's a battery in there. I guess that stores your progress. Oh yeah, this thing had the memory cards right in the controllers. Not to rain on any Dreamcast lovers' parades, but I always thought the controllers for this thing were, how shall I put this diplomatically? Horrible. They just, I don't know, they just weren't comfortable. And you know, that's the thing you hold. That is your interface to the computer or the game console. Whereas PlayStation controllers were quite comfortable. What is this fan doing? It's kind of lazily blowing air out from the unit. There's no real obvious heat sink yet. It says 3.3 volts on this in big letters. I guess that's handy. Let's take a look at this. You know, it's possible that there are solid state drive replacements for this. I mean, this thing has been out, this thing came out 15 years ago. Who knows what kind of add-ons or gizmos have been made over the years. That's all the screws. Let's see here. This probably is connected via a, yep, large connection. I wonder if we could, see this is a big part of it, this big disk drive, like how thick it is. And this would add a ton of bulk to the system. It's a big mechanical drive and there's some sort of driver board under it. Maybe we could replace that because the guts itself, you know, they're fairly thin. Just how thin, I guess we'll see. Oh, it'd be cool to find the network adapter for this and put that in. You know, so you can play on all the up-to-date servers. You know, it's like, oh, we better play one last round of Quake before Y2K kills us all. All right, RF shielding in the base. The metal shielding is contacting some chips, so those are probably the CPU and the graphics. I don't know if it would have been the same chip at this time, probably not. Probably wouldn't have been integrated in 1999. So it looking like there's a thin shield here and perhaps a thicker aluminum heatsink that is bolted to it. I'm not seeing anything else actually holding this together. I have actually taken one of these apart, but it's been years. What is this? Oh, it was the heatsink compound releasing. Okay. Yep, we have a 080 aluminum heatsink there. Oh yeah, they had these same rubber pad things on, oh, what was that? The N64 had these. SH4, okay, that's gonna be your main CPU and this is gonna be graphics there. Let's just put these pads back on. I mean, who knows, maybe we could just reuse that aluminum heatsink. It's already got the proper bends in it. Time to play guess the parts. This is gonna be your CPU, that's gonna be your graphics. This is gonna be your RAM. It looks like it's shared between both of the CPU and the processor. These two are the same. Not sure what they do exactly. This is probably some sort of North bridge or something connecting to your modem or Ethernet. This chip is larger. That might be some sort of connection to the DVD or CD or whatever it's called. I mean, it's fairly simple. This was kind of the rage back in the late 90s. The systems were fairly simple. If you look inside the Nintendo 64, it was very much like this. I'm gonna think that the biggest challenge with this is shrinking down the optical drive or replacing it entirely. I've hooked the Dreamcast up to my bench PC power supply. It has all the voltages that we need, 3 volts, 5 volts, and 12 volts. I'm also going to use my multimeter here to measure the current. So when you measure current, you use the different jack, you go in here, and you put the multimeter in line with the power. So 3 volts or 3.3 volts go into the multimeter, and then they come out here and power the circuit. So we're basically putting the multimeter in line, and we should get a reading from it. There it goes. This multimeter has a nice feature. We can set it to min-max and it will show us the range of voltages or currents that it finds. For instance, the 5-volt line, we have a minimum current of 0.42 amps, an average of 0.44, and a maximum of 0.6 amps. So you could probably put on a 1 amp 5-volt supply and be safe. We'll test the 5 volts, the 12 volts, and the 3.3, and then we'll know the parameters for our power supply. Next, we need to come up with a circuit so we can power the Dreamcast using lithium-ion batteries, such as this battery pack. So this is 2 cells with a balancer, so it's going to be 7.4 volts, although when fully charged, it's going to be more like 8.4. We learned online that you can power the Dreamcast 12-volt line using a lower voltage, such as 7.5. So that sounds perfect. We can drive that directly off the batteries. And when we get to the LCD screen, that also takes 7.4 volts. Perfect. But we also have the 5 volts and the 3.3 volts that we need to provide. We've created a circuit here, which does that. Now this looks a little bit more involved than your standard linear voltage regulator, and that's because they're switching regulators. They require a few more external components than just a standard linear voltage regulator, but the advantage is higher efficiency. So we're taking the 7.4 volts and we're knocking it down to 5 volts and 3.3 volts with the switching regulators. That should give us the 3 voltages we need to power the Dreamcast off batteries. Let's give it a shot. We may rebuild this once we put it into portable form, but for right now, we just want to make sure that it works. So let's plug this in with a handy dandy header. Sega was kind enough to have a 3.96 pitch header already there for us. They obviously knew we were coming. We did learn that you have to have the fan in place, otherwise it won't even boot, probably as a safety precaution. Let's put the disc in place. We'll power our screen with the bench supply for right now. Okay. Oh, let's stick in this visual memory unit that I got. Oh yeah, I can play Tagamaguchi. I guess that's kind of cool. I personally think this controller is atrocious. It's probably half the reason the system failed. Oh, and then here you can see the schematic. It's pretty simple. You basically have a few more components than a linear regulator, most notably a coil. All right, let's get this hooked up. Okay, we've got our regulators, the voltage going in. All right, let's see if it boots up. Well, the Dreamcast forgot the date, but it definitely is running. Oh, it thinks the lid is open. There we go. Ooh, there's a graphic on the little LCD screen. So what I'm gonna do here is just see if the game will boot. All right, it looks like this circuit is working, so we can power the Dreamcast with batteries, but we're going to need a better screen than this little dinky thing. So let's take apart a classic Sony PlayStation 1 screen. I obtained a PlayStation 1 screen off of eBay. These screens are really nice. They were meant for the redesigned PlayStation 1. Came out back in the year 2000. The thing that's nice about them is, well, they have a nice round shape, and you can put a variety of input signals into them. Composite, S-video, and RGB, 15 kilohertz RGB, like an old arcade monitor. And I believe we can get that same type of RGB off the Dreamcast, which means we'll have a really nice picture. Let's crack this sucker open. It's been a while since I used one of these. I still remember a few things about it. It operates off 7.4 volts, which is good because that's the same as a lithium-ion battery, or rather 2 lithium-ion batteries. I think this, oh yeah, this also gets you built-in sound amplification, so that's done for you as well. It's weird to think about. This screen is 14 years old now. I remember when the screen was brand new, just like the Titanic. People came from miles around to look at it. Then it sank. Oh yeah, see, DC in, 7.5 volts. AV multi-out. So you could actually put the PlayStation into this and then it would duplicate all the ports so you could connect it to something else as well. It's a really, really cool screen. Maybe we have to pry this open again. I haven't taken one of these apart in probably 7 or 8 years. Even 14 years ago, electronics had a lot more screws in them than they do today. Screws cost money. It takes time to screw things in. It's better just to glue things together, right? Ah, there we go. I'm trying to remember. One of these is audio. Oh yeah, look, it's labeled. Audio left, right, external audio, and then over here is gonna be all your video connectors. Okay, unplug the speakers. Come on, there we go. Yeah. It's quite thin too. And there's buttons on it for the brightness and the volume, so everything is built in. We'll just replace this part so we can light it using LEDs. Let's test this disassembled PS1 screen with the Dreamcast. We're just going to start with composite video since it's the easiest. I actually found a pinout from my old forums. Should be right there. Woohoo, it works! Now the Dreamcast actually has RGB out and the screen can take RGB in, so we'll use that for when we actually hook this up. But what I want to do next is actually convert the screen to use LEDs, white LEDs for illumination instead of the CFL bulb. This is a trick I used to do a lot back in the day. Haven't done this in a while, but I'm sure it'll still work. So this is your high voltage bulb here. And then back here, let's carefully lift up this. There we go. And now we can slide the screen out. All right. It's like a pancake disc. So the bulb is going to be up at the top, and there's just going to be one of them. We need to take this apart and not get any contaminants inside and remove the bulb and then put LEDs in its place. So there's going to be tabs all around the screen. Pretty much every LCD on the planet works this way. There's a metal frame with tabs around it. If you remove the tabs, the screen will come apart. So we're going to carefully lift these up. Go round robin. Not Red Robin, the official corporate lunch of the Ben Heck Show. If you remember our LCD light box episode, the components inside of this will look familiar. Okay, once I remove this, the glass will be loose. All right, I got a hopefully clean sheet of paper. I'm gonna take this, tilt it out carefully, and put it in the paper. I am crazy, a Russian hacker. That's how you do it. All right, we want to make sure we keep this clean. Now we're going to have to separate the plastic frame to get at the bulb itself. Look, more tabs. What a shock. I wasn't shocked. I've done this before many times. Let's open up the frame. Now there's going to be some plastic layers in here. And here's the bulb at the top. So let's try not to disturb these layers any more than we have to. There it is, see? It's a little compact fluorescent lamp. Oh wait, there are two on this thing. Well, I'll be a monkey's uncle. Oh, look at that. Oh, that's right, it's a U-shaped one. Man, it's been so long since I've hacked one of these. Check that out. Beauty. That's what Dave Jones would say about this. That's pretty intense. So we'll probably want to actually use 4 LEDs to replace what this did. Okay, so what I'm gonna do is I'm gonna cut this with my X-Acto knife and make a slit for the LEDs here, 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 and here. I have to be very ginger about this because I don't want to get it all dusty. Let's fire up the hot glue gun. We'll use that to seal the lights in place. I've replaced the U-shaped CFL with 4 white LEDs. I'm going to put this back together and then we'll build it into the original circuit. Okay, next I'm going to remove the transformer to hopefully reduce the voltage that this requires. This area here is very likely the high voltage circuit. I'm going to remove the transformer and see how much power we can save. I'm going to hold the screen in place with some blue tape. I should have all my drawings of this screen from a decade ago when I was using them a lot, so we don't have to redraw it. Yay. So I think I'm going to use 1 resistor per LED, and this metal can goes to ground, so I should be able to ground each LED to the can and then just have a discrete power lead going into each one. Why does it always get so tangled? That is ground. In a shock to no one, a shocking twist worthy of M. Night Shyamalan. What if he was dead the whole time? Oh my God, you're a genius. The Amish people are living in present day. Okay, I have all the LEDs going to ground. So the next step is to power them. So I'm going to put 7.4 volts through a 220 ohm resistor going to each one, and hopefully that gives us a good amount of brightness. I now have the LCD screen hooked up to the same 7.4 volt line that's powering the Dreamcast. Let's turn on everything at the same time and see what kind of current draw we get from the batteries. The screen isn't fully turning on. We get about 3 amps of draw here. Batteries may not have enough juice to power this whole thing. Let's double check. Let's put the screen, hook it back up to this power supply. I think we're going to need slightly larger batteries in order to make this work. In this episode, we tore apart the Sega Dreamcast, tested it with a bench power supply, took apart a Sony PlayStation 1 screen and modified it to use LEDs instead of the less efficient CFL bulb. Then we tested it with the Dreamcast to make sure all the components were still working. That's all the time we have for this project today, but in a future episode we're going to continue the Dreamcast project, shrinking all the components down and figuring out a basic form factor to put it in, along with some final batteries. You can read about all the upcoming episodes of The Ben Heck Show on the element14.com community. We'll see you next time. Windows CE. I guess that's better than Windows Me. I mean, if you want to go over to the lake and drill a hole and try to catch a fish with your amazing fishing rod there. And the real project, get it, is the Sega Dreamcast. Now I'm going to concentrate, not talk. You look so sad. I'm not sure exactly what you could catch with that little pole there. Maybe a goldfish at the fair, you know, just like trying to sink it into. Ground is everywhere.
The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.